Okay, so moving on a little bit to successive ionization energies. This is where you've already stripped away one electron and you're trying to strip away the second electron. So obviously it's going to get much, much harder because it's getting more and more positive with less and less negatives there, and you just try and rip off all the electrons. So just as an update, I've added a diagram in here just for a first initial explanation. So as the electrons are removed, the charge difference is greater, so the relative number of protons to electrons increases, so it takes more energy to remove the next electron. And so this will always be just for one element. And so you can see here, this is one element. It just gets harder and harder to rip off the electrons and make them all disappear. And the big jumps you would expect from shells. This one is the 2 here, sorry, the 2s. 1, 2, and then 1, 2, there's a 2 here, so that's 1s, sorry. 2s, 1, 2, 3, 4, 5, 6, 6. All right, so this one must be 3s. And so as you can see, I'm not actually correct here with this one. It's got a little bit more detail here. As you can see, the big jumps here, this is not actually 1s, so please forgive me. They've sort of jumped in randomly here, which is fine. When you got the big jumps here, that's going to be because of either subshells or because of complete valence shell jumps, energy level jumps. And so you'll be able to distinguish by counting them. So the 2 and the 6 are clues. There's also this one here. And so this would be the 2 here. This is a big jump, so this would be a 1s to 2s jump. Whereas that blown up is also a jump, and that's a subshell jump. And so once you start ripping away disrupting full subshells or full shells, you get the big jumps.